Hi guys, today we're going to take a look at page 16 of the Unit 2 Classwork Packet. Now, the transformation we're going to talk about today is called a reflection. Now, reflections are actually one of my favorite transformations because oftentimes they can be performed either with a coordinate rule that you can memorize, or they can be performed graphically, at least in the case of transformations over the x-axis, y-axis, and what have you, okay? But we would say that a reflection is a flip. Let me say that again. A reflection is a flip over a line called the line of reflection. A reflection is a flip over the line called the line of reflection. Now this part's very, very important, so put a star by it, highlight it, do something. Each point and its image are the same distance from the line of reflection. In other words, like if I want to reflect my hand over this marker, it's going to end up the same distance away, but just on the other side, okay? So a point and its image are the same distance away from the line of reflection. And we would say that because reflections leave figures unchanged in size, we'd say that it's an example of a rigid motion transformation, okay? Now, in terms of the most common transformations, the ones that happen most often are reflections over the x-axis, or the y-axis, okay? Now they can also happen when you have equations that are in the form x equals a number or y equals a number, or they can happen when you have diagonal lines, for example, y equals x or y equals negative x. But what we're going to do now is we're going to start off super simple. We're going to start off just with reflections over the x-axis and the y-axis. And we're going to show these two different ways, okay? The first way I'm going to show you is graphically, okay? And we're going to take a look at that with example number 1. Okay, so taking a look at example number 1, okay? They give us 3 coordinates. They give us -4, 2. So I'm going to graph that right here. They give us 4, 7. And they give us 5, 1. Alrighty. Okay, so this right here, guys, is my original figure. It's just a, well, for lack of a better term, it's just a triangle, okay? Now, let's say that we want to do this particular transformation graphically. In order to reflect this over the x-axis, remember which one's the x-axis, the flat one, right? All I gotta do is count how far each point is from the x-axis, and then count that much on the other side. Let's take a look. This point is 1 unit above the x-axis. So that means it's going to end up 1 unit below. Oh my god, so easy. Over here, this point right here starts off 2 units above the x-axis. So where do you guys think it's going to end up? Well, it's going to end up 2 units below, right there. And last but not least, this point, oh my gosh, how far above is that? That's like 7 units above. So where do you guys think it's going to end up? It's going to end up 2, 3, 4, 5, 6, 7 units below. And so take a look at what I've just done. I have just performed a reflection over the x-axis. Now that being said, there's actually a far faster and more efficient way to do this. There's actually what's called a coordinate rule for a reflection over the x-axis. So I want you guys to write this down right next to where it says the x-axis. This is important. To reflect something over the x-axis, we can use the coordinate rule x, -y. In other words, each of the x values of the original point stayed exactly the same. What changed was that the y values changed their sign. Let's take a look at how this would work if I wanted to go from the original coordinates. Okay, so I'm actually going to write the original coordinates out for you. So -4, 2, 5, 1, and 4, 7. All right. To apply this rule, all that means is I keep the x values the same, and I just change the sign of the y. So take a look right here. Instead of being -4, 2, it will become -4, negative 2. Instead of being 5 comma positive 1, it would be 5 comma negative 1. And over here, okay, I'm gonna stop being so extra, but you get the idea, right? You just change the sign of the y coordinate. So this would actually be very, very efficient if all I'm being asked for are the coordinates of the new points, right? Now, if I actually have to create the graph of the whole thing, then you might actually want to use the graphical method here, okay? But I leave the choice up to you. You can either choose to memorize the coordinate rule, or you can choose to do the x-axis reflection graphically, okay? Let's take a look at the same sort of thing, okay? And we're going to take a look on the next page with example number 3. Once again, we're going to take a look this time at a reflection over the y-axis. Where's my eraser? Oh no. Oh no. There's my eraser. Sorry, guys. All right. So let's take a look now, guys, at a reflection over the y-axis. We're going to take a look at example 3, the trapezoid. Okay? Alrighty. Okay, so they give us some coordinates, right? So they give me negative 5, negative 2. So I'm just going to write that down over here. Alrighty. Then they give me negative 2, negative 2. Then they give me 0, negative 6, 3, 4, 5, 6, right? Sorry, I really should have written these down, right? Yeah, negative 2, negative 2, 0, negative 6. And they give me negative 8, negative 6, which is 5, 6, 7, 8. Okay, cool. By the way, out of curiosity, guys, how do you know this is a trapezoid? This is actually a preview of Unit 8, right? But a trapezoid is a quadrilateral, meaning it has how many sides? 4, right? Quad stands for 4. And it happens to have one pair of sides that is parallel. These two sides right here are flat, right? So what that means is that they have a slope of 0. And if they both have a slope of 0, that means they're parallel. Alrighty? Okay, so we have two options here. Option 1, and this is my preferred option, is to use the coordinate rule for a y-axis reflection. What is the coordinate rule for a y-axis reflection, you ask? Negative x, comma, y. In other words, this time around, instead of changing the y-coordinate, we're changing the x-coordinate. And the reason for that is imagine that you're flipping this over here. The y values don't change. The only thing that changes is the x values. So, if I wanted to do this using a coordinate rule, I would have to memorize this formula, negative x comma y, for a y-axis reflection. And, well, I have to understand what it means. This means simply switch the sign for the x values. So let's take a look at what happens here. If all I'm doing is switching the sign for the x's, that means instead of being negative 5, this is going to be positive 5. Instead of being negative 2, this is going to be, sorry, I think I'm blocking this, positive 2. Instead of being 0, well, negative 0 is the same as 0, so this one actually doesn't change. And over here, I've got, instead of negative 8, positive 8. Ay, 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 my tech. Oh no. We can still salvage this, people. Yes, we can. Ugh. Okay, now, let's say that instead we wanted to do this graphically. Well, to do it graphically, all I'd have to do is recognize that each of these points is a certain distance away from the y-axis. So this one right here is 2 on the left, so all I'm going to do is put it 2 on the right. This one right here is 5 to the left, and so all I'm going to do is put it 1, 2, 3, 4, 5 on the right. This one's actually on the y-axis, so guess what? It's going to stay there. I'm going to put a little dot right there. And over here, this one was 8 units away, so it's going to go 1, 2, 3, 4, 5, 6, 7, 8 on the other side. And I apologize if my figure... yeah, sorry. This should not be changing size. I apologize for that. But you guys kind of get the idea, right? That basically, I can do this either graphically, or I can do this using coordinate rules. One thing I will say though, The x-axis and the y-axis reflections are the only two reflections, well, I shouldn't say that. They're the two reflections that can be done either through memorization of the coordinate rule, or they can be done by using a graph. The other two reflections, y equals x and y equals negative x, you gotta memorize, okay? So I would encourage you guys to memorize the coordinate rules. They're actually all in a document for you called Graphic Organizer under Modules Unit 2, but we'll get to that later.